So for our second keynote of the day, our speaker is going to be talking a little bit about software security for DevOps and continuous deployment in the cloud. He is the founder and president of Open Systems Technologies Corporation and has extensive experience in this topic. Put your hands together and help me welcome Mr. Thomas Truitt.
Well, I'm a right brain guy, so you won't get any fancy graphics from me. I started working in software technology. To give you a background, I started working in software technology back in 1990 and helping to build the fire control computer software for the F-16 in Fort Worth, Texas. It probably was one of the best experience I've had. But just remember, when you've had 20 years to figure out how to build software, it makes it a lot easier for everybody. But I can tell you, growing up through the years, a lot of you probably remember the Netscape Navigator, browser Mark Andreessen. Anybody remember Mark Andreessen back in the 90s? Now you probably hear Firefox. Mark Andreessen was a pioneer. He spent his time developing this browser, and around the browser, the Netscape company developed a series of servers that basically kind of spun off the web technology, and everybody wanted to do the web. Anyway, before I go into all that, I have had a lot of work done with Fortune 500 companies, government, agencies. I can tell you right now that your government is slow in the U.S., but it tries to be safe. And as you know, in the commercial side of the business, people try to go to market quickly. They make a lot of mistakes. You see a lot of patches. You see a lot of software updates. And truthfully, you see a lot of software security problems. And it's part of the whole process of, first to market. We got to get there first. They have investors. They want to see something, right? But in the government space, they're more slow on adoption. They're like, hey, we don't want to go too fast. We don't want to be the early chargers in general. Let somebody else figure out all the hard stuff, and then we'll try to use that. Anyway, I was educated as an electrical engineer at Virginia Tech. I can tell you that conceptually I've used a lot of it, but things have changed so drastically. Now you have infrastructure as a service, platform as a service, software as a service. You name the buzzword, okay? And I'm actually in the throes of software development. I'm not just a figurehead in my company. I actually am involved in product development, and I kind of call myself the working CEO because it's easy to get abstracted so far that you really don't see the day-to-day problems of what's going on. Now, naturally, I can't do development 100% of the time, but I do make myself available, and I do try to understand at the level I can to help people to figure out what they need to be successful. Just to give you an example, one of you guys probably already heard of Freddie Mac, Federal Home Loan Mortgage Corporation, correct? Well, back in the 90s, Java came out strong. It was coming out, and there was just serverless. Serverless is just a way to get some data and put it somewhere and bring it back. Okay, it's just a mechanism, software mechanism. And at the time, they were all doing Perl. They were doing Perl programming. And if some of this doesn't make sense to you, don't worry. It's just programming stuff. Okay. But I wanted to share this with you to show that hey, where we've been, where we've come from. They were doing Perl programming, and my company was brought in to create a new Java infrastructure for Federal Home Loan Mortgage Corporation, and also to build out their security infrastructure. So fast forward that, it was all on premise. At that time, all the stuff was on premise. We had our own data centers, like a lot of people today outside of the cloud stuff. We have a bunch of organizations that still have their own data centers for various reasons. By the way, all your on-premise data centers are not going away. There's still some reason to have on-premise data center. We still have a lot of data security issues. Who has access to your data? How can you get your data out of a cloud or wherever it is and put it somewhere else? There's always a lot of issues involved in security around data. So currently we've been working on the migration of our applications to a large extent from the on-premise data centers to the cloud. Now, sometimes due to policy, does anybody here have any policy issues they have to deal with? Like, that's a great idea, but we're not going to do that because I'm a technical guy, but I'm also a political person. I mean, I know how people think. I know how the politicians think. I'm in the DC area, so we get inflamed with that stuff. But I do appreciate, what they're trying to do for the public. They're trying to keep us safe, try to keep our data, our PII safe. But today we're seeing a move like never before. A lot of it is, you probably heard the term, on-premise, cloud native, and maybe hybrid. What that means is, on-premise is a no-brainer. Most of you probably grew up doing stuff on-premise, right? I mean, everything's on-premise in a data center that you control or somebody you trust. But due to economies of scale and also infrastructure maintenance, license maintenance, I can tell you the customers don't do a good job a lot of times. Sometimes customers come in, let's say IBM or whatever big company, that you have software and they do license counts and you're over the count and then you get a big bill. The thing about the cloud, it's giving more auditing capability to be able to see, what people are using in real time. You can see the bill in real time. You don't have to guess at this stuff. You don't need an auditor coming into your place. So I just want to go over coding 101 security. When I first started coding, and this is back in 1990, so it's been a while. We were building F-16 fire control computer software. So we weren't really concerned, when you're in the sky, you're in a closed network, okay? You have jamming capabilities, you have radar jamming capabilities to other planes and stuff. There's some capabilities that you care about as far as security, but it isn't like someone is going in the plane in the cockpit and doing stuff because they don't have access to the F-16, So we weren't really that concerned about it. We weren't in the internet age yet, right? We were in the, embedded software control systems age. But as we got into the, age of, hey, internet, we first started out with intranets, if you remember. Some of you out there, you got a little age on you, okay? So I know you remember. They first started out with intranets. It was big. Everybody had their own little intranet. They would deploy, information for employee portals, what have you. And then that migrated to extranets. I remember working with AT&T on the extranet, and that was where you had to have VPN software, a special connection to be secure to get into the network. And, they had this stuff going on worldwide. But there wasn't, from a software point of view, there wasn't a tool available, if you will, to inspect code. See, what you guys put in your little phones, you don't know where it's going. You have a trust in that phone. You have a trust when you put that stuff online, you say, well, you trust the company, right? But more importantly to trust the company is their software has to be security, cannot be vulnerable, or highly vulnerable, I should say, to some of the basic stuff. And there are products out there now. There's an open source site that I've referenced up here. It's called OWASP. And, before, I guess, post-2000, when we got past the Y2K event. We got into e-commerce post Y2K. And then people started talking about, as a developer, most developers, they're concerned about getting their code done. They're concerned about getting the functionality. So what happens is you leave security vulnerabilities. You leave your system sometimes in a state that you don't really know if a certain thing happens, what's going to happen. That's due to, getting the software out quickly. We all have deadlines. That's why we went to school, because school taught us not just what our trade was, but it says you have a deadline. The test is over with at 10:15, and you have to meet it. Otherwise, guess what? That's really, for me, school was like, you have to figure out how to be successful, working with people, working under conditions that are harsh, that are tough, and sometimes unfair, okay? But the bottom line is, now we have OWASP. They actually define some software standards. Some of the basic stuff people miss, like null pointer exceptions. I don't know if you guys, how many programmers do I have in the house here? Anybody programmer? Okay, we got one. All right, it's all good. So, null pointer exceptions, null object. You can't work with a null person, right? Null meaning void. Okay, let's just say it that way. So a lot of programmers, they don't. We're in a market that's continually changing. Some people are very smart, they're up to date. Some are trying to learn object-oriented technology. What happens when you don't look at the security vulnerabilities of your code? You pass that along to the customers, which is a no-no, right? And we're gonna go into some of this real quick. So we have two kinds of threats, right? Insider and external threats, right? So there are people in your organization. They seem to be good people. They passed all the background checks, but they got into some situation where they're more interested in their own ability to make money. Sometimes maybe it could be extortion, maybe it could be just getting identities out of your system or information where they can use to get money with. I know that sounds kind of harsh, but I think I've got a few examples trying to give you something real, because just talking about it doesn't really make it real, right? But when you see examples, you're like, oh yeah, I guess it can't happen. So today we have authentication, we have basic ID password, we have multi-factor, biosecurity, federation. Federation, just machine to machine. You have to say the machine has to know who it's talking to at all times. Generally, that's through PKI technology. We'll get to a little bit of that. Some of the authorization we use today is ABAC and RBAC, attribute-based access control and role-based access control. All that means is all of you people have identity somewhere, okay? You're in an LDAP, you're in a database, you're in some data store, okay? And you have attributes on your account that tells us who you are, what you can do, what you have access to. We use that to paint those pretty pictures that are individualized to you. Okay, breach on the internet. I'm sure everybody heard about the OPM incident this year, correct? Affected millions of people. Some of you may have, they gave everybody a free, you were? Okay. They gave everybody a credit monitoring service, because millions and millions, I don't know the exact numbers, but it's a lot of people, okay? Now, this specific incident, I know the people at OPM, this specific incident could have been avoided by a simple patch that should have been applied in time. It was not rocket science. A lot of the things today, we put consumers at risk not doing regular updates or timely updates to software that are vulnerable to issues. As you probably know, we have hackers. Everybody's heard of the Democratic National Convention. All these conventions, they all have a presence on the net, right? And you've heard through the last election cycle of the Russia involvement and all that. I mean, this stuff is for real. People want to hack us. They want to get information out of us. They want to do it for multiple reasons, okay? We have Sometimes it's financial. Sometimes it's just they want to get information to hurt the United States. Sounds familiar? Anyway, when I was doing some work for the FBI, Robert Hansen was one of the famous insider threat guys. And I kind of talked about some older stuff because I wasn't sure if somebody else would be doing something. I didn't want you to hear the same thing twice because it's easy to talk about, you know, what's in the news today, but a lot of you probably haven't heard of Robert Hansen. Maybe you have. But anyway, he was an analyst and he was doing his job and he had access to all kinds of information in the system. Well, guess what? He didn't like, you know, he had a government pension, a government salary, and he wasn't happy with what he was making. So he decided, hey, you know, I can do better for my family. So all of a sudden, he was caught with, you know, nicer cars. He sent his kid to private school, and they were just scratching their head like, you know, how could this guy be doing that? You know, how could he be sending his kids to a private school? Well, looking through the systems, you know, through auditing his records and what he was viewing, they figured out, and they put 2 and 2 together, opened the case up on him, and figured out what he was doing. And the second example is American Online Insider Threat. You probably heard this from many years ago. There's been other ones, but some employee decided to take off the identities of all the subscribers, or a large number of subscribers, and to use those for his own benefit. None of this is acceptable to us, right? I mean, they have our data. I mean, financial, whatever data you stuck in their system, and it's really against. It's illegal to share that information. You can verify a list of other breaches, more recent breaches. If you ever wanted to take a look, there's a lot. It's kind of scary. That's why we're in the security business, to make sure that you know, it's as secure as possible. There's no such thing as 100% security. So if anybody tells you that, you know, guards, guns, and dogs is what it used to be. You know, back in the physical security days. Now it's on the internet. You're always having some risk. My wife just last night signed up for an Uber account. I was like, are you sure? Are you sure that Uber account is good? I mean, yeah. Okay. We'll talk about on-premise security. You know, you've heard people talk about Agile. We started out with extreme programming, you know, where basically 2 people would get together. You know, they would learn how to do programming together and basically look over each other's shoulder. And then open source has been around for ages. I mean, it's been the blessing of our community to have people that can contribute stuff. They may have another intention to put it out there, but for us, it's freely available. Most of the time, you don't have to pay anything unless you want support. And but it also has a price tag, and I'll talk about that. On-premise security, you have patching, you have log monitoring analysis, you're using tools. When all these events occur, somebody comes in and looks at your account, there's tools monitoring what people are doing with their information, or there should be. And that information, well, if they do something that they're not authorized to do, or they shouldn't be looking at, it gets rolled up to a supervisor or someone who can look at it and say, hey, we got a problem here. Application performance management. If you're in the throes of software development, one of the things we need to improve on is being able to know what is happening in the application at a low level, so that we can predict where the bottlenecks are. There's some instrumentation that is available, but they're still far off as far as the details. And just think about it, if you have somebody else's software on your system, you don't really have their code necessarily. You can't look through their code. It's proprietary a lot of times. They don't want to give it to you. But if you have these tools, they can tell you what you're having a slow connection, this device, that device, whatever you're connected to. And of course, there's always, has anybody ever said, I think it's a network problem? I mean, the network is it's the worst monitored. Most of the networks that I have been involved with, it's the worst monitored piece of IT. Because the network guys always say, hey, the network looks good. I'm like, well, based on what? What do you see? Well, I don't have anything to see. Well, therefore, the network is bad. You can't just say, well, something's good. you don't have any information to really base that on. But today, that's what we see. And the network is a complicated device with a lot of, equipment, routers, firewalls. It's really complicated. And then we've had a release build process from day one, right? So we have software that gets released. It gets generally, in this day and age, it gets scanned for vulnerabilities, and then it gets released through a build process. This continuous integration, continuous development. This continuous integration and continuous development, continuous integration has been around forever. It's just gotten more formalized, and I'll talk a little bit more about that. But the whole idea is this. As this gentleman said, the user experience is number one. We want to make sure that you get input on what's going out before it goes out. You say, I hate this, it's not good, you need to do better. We try to get the input quick. So that's what it's all about. Okay. Continuous deployment, continuous integration. You probably heard the term DevOps. DevOps, DevSecOps, okay? The whole thing is the people that make the software, okay, the developers, they're the ones that know how to operate the system because they developed it, right? They know it. So basically, when there's production issues, something happens that shouldn't happen, they're the ones you talk to. Those are the people that can give you input on, hey, we're having an issue, figure it out quickly. But the whole thing is, it's not just about making the product. How many of you have deployed a product and errors abound? It's like, what is going on with this thing? I can't do anything. It's slow. Some of the stuff isn't functioning properly. That's what the DevOps teams does. It's the development and the operations people getting together and knowing, hey, what is going on in real time? Because when the system is down, guess what? It's almost like the house is on fire. If you've ever been a part of a fire, some emergency event, it's like when systems go down, people start scattering. It's like, hey, this system has to come up. We actually had an event yesterday. We had a data center that had an acid problem. I got a call upstairs. We had a couple people had to go home and get checked out because, naturally, that's a big deal. We don't want people to get sick. But, after that event, we had a power failure, and like I say, people scattered. Hey, either you got to transition to another site or get your stuff up and working on the current site. So DevSecOps, just talk about that for a minute. DevSecOps is now, it used to be development operations. They've got security involved in the whole process. And to be honest, it's been there for eons. But another one of these terms that they've formalized, and basically, formalization gets it out to the masses so that, hey, when you hear this stuff, oh yeah, I know what that is, versus I have no idea what this guy's talking about. So what it does is, when you're developing software, you have security in mind. How big can the input be, right? For example, what kind of input am I going to allow? How am I going to connect to this thing? Is it a secure connection, unsecure connection, those kinds of things? So it's critical to get the business community on board with, hey, we're doing things the right way, we're doing things that are secure. Some of the modern software tools today, you'll see in the cloud, is Maven, Git, Atlassian Suite, Jenkins, some code quality tools. I won't go over all the tools, but I wanted to show you that, hey, as far as continuous integration, continuous development, in the cloud, these are some of the major players when you're building software, Maven and Git. And their Atlas and Suite, what that does is, and all this stuff is in the cloud too. There's nothing on site, okay? And what this does is, this automates the whole process of this continuous integration, continuous delivery. And of course, you have to have, getting back to security, you have to have privileges to run this stuff. You have to have security set up. Some of it is ID password, but right now we're going through all PKI. We have projects where it's all PKI. So if you don't have a token, I'm talking about a hard token, and you know the PIN for that, you're not going to get in the system. There's no ID password is going away, but it hasn't gone away completely because of the adoption of some of the agencies we work with, and some of the clumsiness of, we have everybody has a cell phone now, and they all don't support the same technology. So that's pretty big in this industry. So some of the security standards, we do a lot of work with the government. You'll hear about FedRAMP, FISMA, FIPS, and PTI. Some of this stuff, just to give you an example, like FIPS it's basically the algorithms by which I can connect to somebody, and we can agree to connect a certain way. And it's all vetted. It isn't like, well, I trust you because of, we have a vetting process to do this. PKI, does everybody have a token? Like at least one X509 token? Or anybody have any tokens, smart cards? No smart cards in here? Wow. Okay, so smart cards is here. I mean, it's been here forever. Especially in the government space, you see a lot of smart cards because they want to be as safe as possible. And but I don't see a lot of bio stuff. I heard a gentleman yesterday talk about biosecurity, like with your retina. Or there is some fingerprint stuff, but it's not in the masses yet. Anybody who has an iPhone, you can authenticate with your iPhone, right, with your face. Does anybody do that? Anybody do that? Yeah, it's pretty neat, isn't it? Except when it doesn't work. Then you have to put your passcode in it. Okay. Okay. Challenges in the cloud. Cross-domain security, single sign-on, continuous software updates. Okay. Quick and easy. You've got Azure, just as an example, by the way. You've got Azure, you've got Google, you've got AWS. They all have different system security. It'll tell you, hey, you can use LDAP, you can use Oracle, whatever. You can use whatever data store you like. The problem is, big companies, large organizations, they don't have one application. They have 150 applications, and they want them all to talk. They want you to be able to log in and talk to all of them at the same time, with different clicks, of course. But once you get your single sign-on, you log in. When you go to that next application, you're not prompted again. They know all about you. Hey, what authorization you have, what you can do in that application. As we go to the cloud, this is going to be a problem for some organizations. It's already been solved, but it's a problem because you're going to have some on-premise applications, the old legacy stuff, where your applications a lot of your applications probably still are. Then you have all the cloud stuff, and you want it all to work together seamlessly, right? So part of the problem is continuous software updates is, as this, in the background, there are updates happening. Like everybody knows the cloud you're never there. You're always moving forward. There's always another update. The question is when you should apply the update. Sometimes you have a choice, and sometimes you don't have a choice. And that's really going to be the ongoing saga for security people and software people to keep the systems to a level that is functional so the consumer doesn't see an issue, but it's still secure. Okay. I'm going to give you a quick example of kind of just led into that security agnostic. In other words, when I sign on once, how many people hate it when you have to sign on like 10 different times? Like, everybody keeps telling me to sign in. I mean, I can't even, especially if you're doing ID password, guess what? I don't remember that. And what do they tell you? Don't write it down. It's like, I can't remember all these passwords. For give you an example, we got one, everybody's got a different change password rule, and they've got a different password construction. Oh, the password has to be 15 digits long, or 15 characters long. Oh, by the way, you can't use pound. You can't use exclamation point. And then another system that does something different, right? I mean, a minimum 8, you can use whatever you want. I mean, there's so many permutations of this. And the average person's like, this is ridiculous. I mean, I can't remember all this stuff. So that's part of our problem as technologists is we've got to find a better way for people to, be comfortable with authenticating at a level that makes sense, but not have to deal with all this rigmarole So we're going to go talk about an example of moving security in the cloud edge with Akamai. Yesterday, there was some discussion, 2 minutes. Yesterday, there was this discussion about the edge. Guess what, guys, girls, ladies and gentlemen? Akamai, we're already doing this with Akamai. I'm just bringing this up as an example. They're just one company. What we're doing is we're moving security rules outbound all over the world, okay? We're doing single sign-on all over the world. This single sign-on capability can go into any number of domains I was talking about, and it can reach back into any infrastructure. It could be on-premise, it could be the cloud, doesn't matter. As long as we set up the connectors, the secure connectors, it doesn't matter. So I just wanted to bring that to an example that, hey, security is moving to the edge also because it's faster. This gentleman talked about it, the experience of the user experience. Well, you get a better experience when it's closer to you, right? And that's what we're doing. I think that's about all the time I have time for, and this is my contact information. I'll be glad to speak to anybody after this, but if you have a quick question, would love to talk to you. Anybody? Did I confuse you that much? Like, what is this guy talking about? Yes, sir.
Recently I heard about zero-day. So typically even
Where were you at?
here,
Thank you.
when a hacker comes into this ecosystem and they
Yes.
start accessing your data, even when an enterprise has some machine learning enabled, AI enabled security software, it looks for a pattern. So it takes days, weeks,
Yes.
perhaps, to detect that there has been a breach.
Yes.
I recently heard about zero-day vulnerability where you can catch that there is a malware or an external program that has come into the ecosystem the moment it is there in the ecosystem. So can you throw some light on that?
Well, I can tell you this, that these vulnerabilities are happening all the time in real time. We have, for instance, we have scanners. If you upload a file, if you do something on the system, we have scanners that look for certain patterns and stuff. But as new vulnerabilities, as new exploits come out, we don't have it yet. I mean, we don't know what they're trying to do sometimes. It's just, we have, security is an evolving process and it's an evolution. We scan the systems, we scan the data coming in, but at the end of the day, if there are new exploits, either we can decide to let it through or not, based upon whatever criteria we're using. But it's not when somebody tells you there's a zero exploit system, it has to be disconnected off the network, if you want a zero exploit system, you have to be in a very reclusive place with maybe 1 or 2 people. Then you might be okay, but you got 2, so it's still a problem. But yeah, it's still we still face large challenges in the security room, and it's not going away. People find a way to do things. You probably don't hear people's computers are all infested now. Like it used to be antivirus was not good, and then the system would be, I downloaded this thing, and now my system doesn't function at all. There's less of that today because of the information we have to combat those things. But still, we're all taking risks being connected. But it's not high, depending on which site you go to, it's not that high of a software system versus others, but as a consumer, you don't really know that. Thank you for your time.